everybody, Wilfie here. Just on my way to work. Oh, duckies! There's cute ducks in the road. Get out of the road, guys. You're gonna get squished. Nah, people in this neighborhood are good. They won't hit the duckies. They're cute. They're not geese, so people don't hate them. Right. So I kind of don't remember what I've posted about my Ceph shenanigans, and I'm on the road, so I'm too lazy and distracted to look it up. Sorry. So I will give you the the history of the project and current status and upcoming plans. So if you saw Ceph in the headline or in the title of this video and you clicked to watch, you already know what Ceph is. Oh, by the way, sorry for the vertical filming. I just can't get the mount stuff to line up so that you can, do landscape and still see me through the steering wheel. So whatever. This is how it's going to be. So short version, Ceph is software-defined storage. Really basic idea. Take a bunch of computers with hard disks in them, stack them together in a network, type a bunch of keys, push buttons a lot, and then all of a sudden, all the disks that you've plugged in through all the computers that you've connected to this thing all pool together into one giant bag of space. Giant bag of holding, I guess. And it's self-healing, it's redundant, it can withstand node failures and disk failures and all that jazz. They have built petabyte systems with this thing, which is, if I remember right, it's megabytes, gigabytes, terabytes, petabytes, and I actually think they may have gotten to exabyte with some of the supercomputer clusters that are using Ceph. So this thing is battle tested, it's been around a long time. It's neat stuff. You can store just regular, you can put objects in it. You can use it as a SCSI target for iSCSI, so it does block support. And it also has a file system on it, so you can export it over NFS, or you can mount it native. There's even a Windows driver now for it, which is kind of neat. Linux, of course, just supports it out of the box. So that's the basics. Normally you run it on really big machines. Well, traditionally big machines. They say it runs on commodity hardware, but really you're supposed to throw servers at this thing, like, the rack-mounted things that you buy from Supermicro for $2,000 a piece. Nobody figured on me doing what I'm doing. So I'm using Odroids, HC4s, little breadboard computers. They're like Raspberry Pis, only with much better specs. And they are ARM-based instead of x86. The ones I'm using, HC4s, are 64-bit machines. They each have 4 cores. There's 64-bit, 4 gigs of memory, and most importantly, they have 2 SATA slots, regular old 3.5-inch form factor SATA, and they come in a little case that looks like a toaster. You just slot the disks in, and boom, off they go. Hot swap support and everything. It's awesome. So, on paper, Ceph supports ARM64. And it also can operate in low memory conditions or environments. And I know this because I asked them a few years ago when I first started thinking this stupid idea up. I'm like, guys, this thing's awesome. Can I run this on bitty boxes? Will it work? And, I described my idea, and they're like, yeah, it'll work. Not going to be the fastest thing in the world. And I think the only limit they told me it would experience, apart from kind of not the fastest in the world, especially over gigabit Ethernet, this thing's not going to be fast. They said the only slowdown would be during any kind of recovery or rebalance, because that's apparently kind of memory intensive. So if there isn't enough memory for it to really spread out, stretch its legs, then that's going to run kind of slow. It can do it, it's just not going to do it as fast. I'm okay with that. So, I posted an introductory video, probably a month ago, because I'm lazy and whatever, and I showed the 4 HC4s that I had lined up that I was getting ready to set up and test. I did record a bit of footage of me playing around with it, getting it set up, but that footage is really dull. It's literally just me sitting there, plugging in flash, unplugging the SD card, flash disk, plug in the SD card, unplug the SD card, because the first node that I was playing with just so happened to decide to be a jerk and not boot reliably. I did figure out why, and that's going to be that's going to be right now. So the short version, too late, I got a 4-node Ceph cluster up and running. Started with 3 nodes because that first one was misbehaving, and it worked. It works just fine. The file system works, and I copied stuff to it. It, as promised, was not the fastest in the world. I got like 50 or 60 megabytes a second out of it, which is pretty damn good for a networked file system distributed across 3 separate nodes over a gigabit Ethernet network. That's damn good. So I'm happy with that. Then I got the 4th node working, and I'll explain how in just a second. And as soon as I added that 4th node to the cluster, it instantly spun up, connected, said, "Oh yeah, I've got some space, by the way." And the cluster automatically, without me doing a damn thing, I'm telling it to do this, it started automatically rebalancing the contents of all the disks on all the nodes, so that it was more redundant. In case, it was just neat. It spread the data out automatically. I didn't have to tell it to do that. It just figured it out and started, which is just fantastic. And for grins and giggles, I unplugged one of the nodes just at random. I think I unplugged node 3, and the cluster noticed the outage and rebalanced all the storage onto the 3 that were left, which is just cool. Then I plugged it back in, and it rebalanced back. It's just awesome. So I'm really happy with that. The reason that the Odroid, the first one, was having so much trouble starting up, as it turns out, there is a bootloader. There's 2 bootloaders on the Odroid HC4. Most of the Odroids actually do this now. One of them is just a very basic, just dead simple, is there something I can boot from either in my flash memory or in the SD card slot or on one of the SATA disks. That's all it does. And if it can't find anything on, that's not true. By default, it will boot what's in its own flash memory. And by default, oh hey, traffic, that's going to be fun. And by default, the HC4 and a bunch of the other Odroids in flash, which is separate from eMMC and the SD cards, it's a chip on the board. They have this thing called Petit Boot or Petite Boot, PETITBOOT, and it is a really cool bootloader that it's so sophisticated it can install operating systems from media that you attach to it, either USB or flash or whatever, and it can also connect to the internet do a DHCP setup or static IP, whichever. Connect to the internet, download. It's got a whole bunch of different OS images it knows how to download. It can basically do a net install of whatever OS you want, which is really cool. Unfortunately, it is not always... Oh, and the other thing, what it's supposed to do is that when Petite Boot, that's what I'm going to call it, when Petite Boot comes up, it's supposed to check other attached storage, eMMC, the SD slot, SATA if it's sitting there, USB or whatever, and if it finds a bootable device, the stock configuration, from my understanding, is it's supposed to boot from that medium instead of booting itself, into the Petite Boot environment. Well, as it turns out, that's a bit flaky, and for node 1 that was giving me so many fits, it was just not doing what it's supposed to do. It was just always booting into the petite boot menu instead of booting off the damned SD card like it was supposed to. The cards were all fine, the image is fine, and there was nothing at all wrong with any of the hardware. It was just the bootloader being a bit flaky. So there is a fix for that. There's a few fixes for that. And I have settled on the nuclear option, which, not so nuclear, it's just very firm. So the Ceph cluster that I've installed so far on the 4 nodes is based off of, is it Debian? Yeah, it's Debian. A Debian image. And it just uses the Ceph ADM command. You install Ceph from the official repositories from Ceph, ceph.org, and it uses Docker to set up the whole thing in containers, which is pretty slick. It means you can start up and shut down a node pretty quick and easy, and it sets up all the, well, I thought it did. It sets up all of the admin stuff so that it can run across multiple nodes if you need it to, along with the manager dashboards and that sort of cool stuff. And so that was all set up and running. Then one thing I did discover, I had just let it sit there and run for a couple of weeks just to make sure it was stable. And for whatever reason, one of the Odroids, I think, and it was the one that I started the whole thing on, it was the bootstrap node, it decided to just fall over. It didn't, for whatever reason, it just stopped. Like, you couldn't shell into it, couldn't ping it, whatever. And the hardware's fine, it was just something crashed, made it stop running. Could have been a power flake, it could have been anything. Who knows? But anyway, the upshot is it stopped running. And it happened to be the bootstrap node that I knew had all the admin stuff on it, and it was supposed to install all the admin stuff on the 2 other nodes I set up, which were 3 and 4. This node was node 2. I left node 1, the broken one, I left that numbered as 1, just so I could remember which was which. But anyway, node 2 was master, I guess, or the bootstrap. 3 and 4 were also manager and monitor nodes, because you're supposed to have 3 in a cluster. So node 2 went down. Now, by all indications, from what I could see, which wasn't very much, the cluster itself stayed up, and it didn't fail, and from what I could tell, it didn't lose any data. But and incidentally, the fix was just to reboot node 2, and it came right back up. But I did discover a screw up that I made probably during installation, and that was that nodes 3 and 4, and of course node 1 because I didn't set it up as an admin, but 3 and 4 also couldn't do admin related stuff, or at least I could not for the life of me figure out how to get the admin commands to work. So I couldn't actually ask the cluster, yo, what's up? I couldn't get any status out of it. Come on, you dolt. There you go. I couldn't get any real status out of it. I dug through the containers and found logs and that sort of shit, and it did see the down node, and it was okay. It figured out what to do, and it dealt with it, which was awesome. I'm really impressed. But obviously I screwed up on some part of the installation process and managed to not get the admin stuff installed on it correctly on those 2 extra nodes. So I got to figure out what I did wrong and go fix that. So next steps. Now that I know that it works, for Christmas, one of the things on my wish list, I put because I've never played with it before, partly, and I wanted to see, I put a MikroTik 24-port Ethernet switch on my Christmas wish list, and it was only $150 because it's not it isn't a router. It's running. Actually, I don't think it's got a web UI, but it's just a switch. It's not. It's just layer 2. It doesn't do anything smarter than that, and it does actually have some routing features, but it's mostly just a switch. But anyway, I'm just going to use it as a dumb switch for now. But it's got 24 ports, and I figured I was always figuring on using more than 4 nodes for this Ceph cluster, so I ordered 8 more HC4s. And yes, I have enough old disks laying around to fill these suckers up. It's kind of scary. So I have, well, they've already come. I've got them already. So I've got a total of 12 Odroid HC4s now ready to go for experiment number 2. I'm going to switch over to using a different distribution. It's called Armbian, which is sort of it's based on Debian, if you couldn't guess by the name, and it's tweaked and customized for ARM-based single-board computers. And the cool part is they explicitly support the HC4. Like, they provide images for the HC4 directly. It deals with all the quirks, what little quirks there are, and it does some pretty cool stuff. Like, it mounts a compressed RAM disk for logs, so it's not constantly writing to flash, like to the SD card, which is super good, because it's gonna, otherwise you're just gonna completely destroy an SD card over time by running Linux on it and not preventing excessive writes to it. You're not meant to write to an SD card all that much, despite what the manufacturers will tell you. They've got a really short lifespan when you're doing a lot of writing to them. There's a reason that that there is such a thing as high endurance SD cards, and there's a reason why they are more expensive, and that's because they use a different kind of memory cell on them that is more durable. It can take more write cycles, and technically erase and write cycles, before they stop working. The regular old El Cheapo consumer grade SD cards, you're going to be lucky to get 1,000 writes out of them to each block, which is kind of scary. And so, fun fact: if you've gotten yourself comfortable and with using SD cards and everything, keep backups, because they are flaky as hell. And if you're going to have something embedded like anything where it's a pain in the ass to change the card, stuff like dash cams, cell phones, anything where it's a permanent-ish installation, use a high-endurance card. Don't focus so much on speed, because they're all getting pretty fast at this point. Anyway, that was a discussion out in the weeds, sorry. So, right. Anyway, so Armbian does some really cool stuff. Compressed RAM disk for logs and other such fun things. Some other tweaks here and there for the Odroid HC4 hardware, and otherwise it's just plain straight Debian, which is awesome. So that's the image I'm going to work with. It supports Ceph. I did test that with a single node bootstrap on node 5. Ooh, he almost hit that car. I'm so glad I'm almost out of this. Oh, why didn't I stay home today and just work from home? Everybody else is. Anyway, it all works. Now, the only wrinkle with Armbian is it is explicitly stated, and there was a thread on the Odroid forums about this. Petite Boot really gets pissed when it sees the Armbian image, and it's nothing wrong with Petite Boot. It's just that Armbian's boot arrangement is quite a bit different. I need to get over. I'm looking over Dead Dog Rover. I hit with my power more. I'm not an alien. So, right, if you flash an Armbian, I need Armbian, an Armbian, god damn it, Armbian image to an SD card and stick it in an HC4, Petite Boot will shit its pants and do nothing. It'll refuse to boot it unless you go into its command line interface, run a command, and all that shit. But the good news is there's a little tiny button on the bottom of the board that you can, you push it, or hold it down while you're powering on the Odroid, and it will skip Petite Boot and force it to try to find a loadable image on an SD card or a SATA port or USB or whatever, and it'll boot from it. This works. So, very first startup, you hold down the button and you plug it in. And boom, you're in Armbian. And it does the all the initial setup stuff, piece of cake. And even during your first boot, you can go right in and there's a really simple command you run. All you have to do to get rid of the problem is just go in and wipe the flash clean. Just get rid of Petite Boot entirely. Get rid of it. You can always reload it later. It's not a huge chore to do, but you just get rid of it. Erase it from flash. And that makes the built-in bootloader that's, I think, baked into the ROM. That makes it just grab whatever it can. Go to SD card, whatever. And so that works. You just flash out, erase Petite Boot, and you're good to go. So that's what I'm going to do next. I'm going to slap Armbian on all 12 of these mofos. I've got some SSD, some 512 gig SSD disks, or SSDs. I guess that's redundant. And I'm going to use that for the monitors and for the metadata servers for the file system thing. So there's the monitor is the daemon that keeps everything running in the Ceph cluster. It's in charge of handling failovers and node replacements and oh shit, he's moving fast, and assorted sundries and fun things. God, let's go. Woo! 0 to 60 eventually. But anyway, the one thing I noticed was the monitor can use a decent amount of data on its own. And I think it's going to fill up. It's one of those things you probably don't want to be constantly writing and cycling on an SD card. Plus, it kind of halfway filled up a 16 gig card already, and that was with very little use. So I looked up the requirements for it, and it turns out you could need some gigabytes of space for the monitors. So that's what the SSD is for each of the monitors. And we're going to go, I'm just going to mount, and they don't become, those SSDs don't become part of the Ceph clusters, like cluster storage. It's just going to be a mounted file system for each of the 3 nodes that are running managers. And I'm just going to slap varlib Ceph, I think, or var run Ceph. Just stick it in, or mount it right there, and let Ceph do its thing, store all of its crap on an SSD, which should be a butt-ton faster than SD cards anyway. And then on 3 other nodes, so like nodes 1, 2, and 3 are going to be the monitor, manager, and storage, fun times. Nodes 4, 5, and 6 are going to be the metadata servers for the Ceph file system part, and they are also getting SSDs, but the SSDs for those 3 are going to be they're going to be added to the cluster as storage, and it can tell the difference between SSDs and spinning Rust, so it'll create a separate pool for the SSDs, and I'll just set up a metadata pool for the file system to use on those SSDs. And oh shit. Wow. Traffic's insane right now. Why I shouldn't leave early for work. Right, I'm sorry guys, I'm really babbling this morning. Right, continuing on. Fucking Christ. Metadata. The servers store all the crap that makes a file system work, like inodes, file attributes, file sizes, directory names, path names, all that crap. Checksums and other fun things. So they're basically what makes the file system work. The storage nodes just see the file system data as chunks of data. They don't really care what they're used for. So when you mount the Ceph file system, you're actually doing it by connecting to one of the metadata servers. And that is the server that you talk to when you've mounted the file system. And the cool thing about it is that supports failover, so if the manager you connected to dies, your client knows about the others because the cluster tells it, and it can fail over to that if your metadata server dies. So anyway, yeah, metadata gets stored on SSD as well, and that makes things fast. The first iteration of the file system I created was on all spinning Rust, and the best I could get was like 25 or 30 megabytes a second on it. When I swapped out a couple of the spinners for SSDs and recreated the file system with metadata on SSD, that doubled the speed. So that was where I got 50 or 60 megabytes a second. So that's definitely a pattern I'm going to keep. I get the feeling that having the monitors also sitting on SSDs is going to make them a bit quicker, and that very well could improve performance on the file system too. So that's it. My next step is going to be building up a 12-node cluster, getting the basics set up, and then shoving disks up all of the nodes. Since I've got 6 SSDs, that's obviously going to take up 6 slots. And each node has 2 slots, so 12 nodes, that's 24 slots total. 6 of them used for metadata and support and all that crap, so that leaves 18 slots for disks. And I think I've got 18 disks laying around. I know I have at least 12. Oh yeah, definitely have 12. So that's enough to make sure that every node actually has a storage daemon running, at least one. And I've probably got enough to fill them up, to get the extra 6 in there to fill up all the slots. And we will see how this thing performs on shitty hardware, comparatively speaking, and a slow-ass network set up by an admin that barely knows what he's doing with Ceph. We'll see how it performs. So I'm kind of excited. So far, so good, though. I'm really impressed with Ceph so far. This shit is definitely enterprise-grade stuff. Because the various failure modes that I've unintentionally put it through, and the intentional ones, it's gracefully recovered from every single one. And if I can't break it, nobody can. Yeah, so that's fun. The cool part is, even ordering 8 more of those Odroids, they're only like $70 a pop. So, but still, it was only a $500 order. $500, and 32 cores, 32 gigs of memory total, and 16 sockets for SATA drives. That's she's cute. And but yeah, what a bargain. And that's kind of the other neat part. These you don't just have to run Ceph on these nodes. I'll get a better feel for how, I'm sure Ceph is going to chew up a bunch of the computing power of these poor overworked nodes. But there's got to be some cycles left, I imagine. So I'm going to get a better feel for that, and for resource consumption and all that fun stuff, and see if I can't also use the cluster for other cluster-like things, which I think will be really damn fun. So, yeah, that's going to do it for me for this rambling update. Sorry I kind of all over the map. Driving is fun. Yeah. But yeah, that's going to do it for me today. And hope you guys are having a good week so far. And I will catch up with everybody later. Shit. Stupid traffic. Take care, guys.